Welcome to Quantum Kinetics Corporation. I'm your host and CEO, and today we're going to talk about how the electron and the positron stay in a stabilized orbit and how that's important to the update function of the entire universe. So if you're interested, go ahead and stay tuned to the end of the video. So before we begin to understand the actual inside behavior of electron-positron reaction, we have to first understand that the electron is composed of electrostatic charges and also a magnetic charge. And that same goes for the positron. And as you can see here in this diagram, the electron is negatively charged and thus it's chasing the positively charged positron. And the positron, since it's positively charged, it's chasing the electron, which is negatively charged. This is an important fundamental understanding of the electrostatic field, and now let's talk about the magnetic field. So now that we've talked about the electrostatic field relationships, let's go ahead and talk about the magnetic field relationships of the electron-positron pair. It's very interesting to know that the electron, when it's doing its update function while it's chasing the positron, it's in the north configuration. And once it passes a certain point, it then becomes a south. And these charges, they actually flip between north-south continuously. And every time they flip, just like the Jenna-Bekov effect, that represents one moment in the universal time clock. And it's very interesting to understand that this spiraling action of the update function of a positron-electron pair is extremely fast. We're talking like 6.2 times 10 to the negative 34 fast. I mean, this is like at the Planck constant scale. These things happen very quickly. However, since these are small particles, you can actually get that relationship update function to slow down if you coalesce these together and make a bigger and bigger and bigger atom. This is called, fundamentally, gravity. As we know, gravity is also associated with time, and time is associated with gravity, much like the relationship between the electron and positron spinning around each other. So how do we determine time at the human scale? That is determined by clocks, and those internal clocks have periods that click once, twice, three times, and it sets a period so we know that that is what's happening at this scale, and we can determine our reference frames from that. But you see, at the electron scale, where you're dealing with stuff that's very tiny, the reference frame of time period domain is very fast, and that fast spinning flip of the Möbius ring or Möbius strip is what we're talking about here at the fundamental level. So the next obvious question you're probably asking is, if this is a negatively charged particle and this is a positively charged particle that's very, very tiny and they're chasing each other, wouldn't it just logically make sense that they would just fall into each other continuously and just explode in pure light? Well, actually no, because inside each one of these is a positive light potential and a negative light potential. And as they get closer and closer and spiral down into each other, they actually all of a sudden get repelled by each other by their internal light momentum. So the internal light momentum of the electron and the positron is exactly defined as a chaos theory event, where the blue represents a perfectly stabilized orbit between a chaotic outward action and a dampening inward action. So if you look here, you can see that the red being the electron, which likes to emit electromagnetic radiation or likes to push out positive light, but you can also see the antimatter, which has negative light, which wants to pull in. And so this symbiotic relationship creates a totally perfect orbit of an entity called the electron. When the positron and the electron are stabilized with their fundamental force lines inside of them, you can actually get this really amazing orbital. And the orbital also correlates to what we talked about before regarding the Bessel function. As you can see, at cosine relationship, you have a perfect orbital. But if you drop down in the sign, you get a pressure differential between positive and negative, thus electromagnetic radiation is emitted into free space. It's an important distinction to say that the chaos theory and the catastrophe theory are two separate theories. And in this situation, we're blending them together so that we can make the Bessel function work with the update function time domain of the electron-positron pair. So this chaos theory orbital can be actually represented by an equation called Planck's constant. And the Planck's constant is E times h bar over v, which means E is the energy output times or equals the 6.2 times 10 to the negative 34 joule seconds, and whatever you get out is the frequency emission. So what that basically means is that this time clock is really, really fast and really, really small, but if you move it or perturb it, you're going to get a frequency out. Just like we talked about in the other episodes, courses, that if you mess up or deflect or disturb or vibrate the electron-positron relationship orbital, you will get an electromagnetic radiation to emit out into free space. And so this is the fundamental relationship between electrostatic charges that are spinning around each other, a magnetic field that's flipping up and down, and then the only thing left in the equation is the resistance. And that is actually called resonance. And when you start getting a resonant circuit that has purely resistive characteristics, you are now creating a singularity. Thus, you've created the analog of the entire universe. An important thing to realize here is that the update function of the electron-positron relationship determines the time clock or the time frame of the universe. And at the really tiny scales, the size of an electron, it's really fast, and almost so fast that we can't even detect it, because it's basically, when you try to measure it, you can measure its energy, but you'll never know its location. And if you try to measure its location, you'll get its location, but you'll never know its energy. And so this particle, or these two particles, are kind of functioning in a hyperbolic state where they're basically super luminous. And basically what that implies is that if you condense more and more and more of this material, you can actually slow down the time clock of the universe. So let's say if I have a gigantic planet versus a really tiny electron, the electron doing the rotational action of the electrostatic versus the magnetic fields causes us to know what the time is. And by the way, that's very fast out in free space. But if I get next to a large body object with hundreds of trillions and billions of these tiny little update clocks, that the time begins to slow down. And we notice that very much so in the Jenner-Bekoff experiments. When you have a larger object, it'll rotate slower versus smaller objects. So it's very important to understand that there is a relationship to the time clock speed rate and the amount of matter, electron-positrons, you have together in a localized space. Thanks for checking out this course content. If you like it, go ahead and make sure you like, share, and subscribe. Share with your friends, helps the algorithm push us forward and get this technology to you as fast as possible. And remember, fusion is love, and love is fusion. You don't have to force it, it just happens. We'll see you on the next one.